Hey guys, I'm just going to go over some of the math questions I gave out the other day. I had a request to go over number 1, 4, 6, 20, 23, 24, 25, and 26. So I'm going to start off with number 1. Sorry for the few scribbles here. I made an error because it's early in the morning and my brain's not quite awake yet. So volume of, so we're trying to see how many square feet it's going to take to make this cylindrical tank. So it has a diameter of 3'6". We don't know what the height is yet. We do know that it holds 525 gallons. So the first thing I did was change this to inches, because we're dealing with cubic inches when we convert our gallons. So first thing I do here is I change the gallons into cubic inches. So 1 gallon is 277 inches. So I just multiplied 525 times 277, gives me 145,425 cubic inches. To find out the volume of something, it's pi r squared times height. So doing the pi r squared gives me the area of the ends. Now this container is going to have 2 ends, so I found out the area and I multiplied it by 2. So I have the area of the top and bottom right here to the pi r squared. I did all the math right here for it. So the radius is going to be 21 because the diameter is 42. So squared times pi gives you 1385.44236. Multiplied that by 2 and got 2770.88472. Now the body is going to be the area of the body, so it's going to be pi times diameter, which gives me the circumference of the circle, so the stretch out, and then times the height. Sorry, I kind of jumped ahead here. We have to figure out the height. So to do the total volume, it's pi r squared times height. So once I have the area of one of the ends, so area times question mark is going to give me the volume. So because it's a linear equation, I can have the volume divided by the area of the one end, and that's going to give me the height here. So that's where I got this 104.9664744 inches. So that's the height here. You can see I put it there. So now the area, the circumference, pi times diameter. So pi times 42 gives me 131.9468915 times the height will give me a stretch out of 13,850 square inches. So that's where this is. I have the top and bottom area, the body area. I just add those two together. It gives me a total of 16,620.88472 square inches. This answer needs to be in feet. So it's going to be divided by 12 squared, or 144, which gives me a total of 115.423 square feet. All right, hopefully that wasn't too confusing. Move on to number 4. This was an air changes per hour. So this had a room that was 18 feet wide, 42 feet long, with 9-foot ceilings. So I just drew a little drawing to help us out here. So volume is going to be length times width times height. So 42 times 18 times 9 gives us an area, or volume, a volume of this room of 6,804 cubic feet. This room is getting supplied with 1,238 cubic feet per minute. So we need to, an air change has to do with the volume of the room being supplied and exhausted within an hour. So there's 60 minutes in an hour. So I'm going to multiply the cubic feet per minute times 60, which is going to give us a cubic feet per hour. So 74,280 cubic feet per hour. So now how many times does the volume of the room go into that cubic feet per hour? So it's 74,280 divided by 6804, which is going to give us 10.917. Like, this is the full decimals, but it's just asking for the closest three decimal places. So just about 11 air changes per hour. So 10.917 air changes per hour. All right. Moving on to number 6. Number 6 is a Q equals VA question. We have a 52-inch diameter duct. It's a round duct. It has 2100 CFM going through it, which is barely anything for a duct that size. So a Q equals VA. Q is quantity. We know what that is, 2100 CFM. Our velocity is what we're looking for, so that's the question mark in this question. And then our area is going to be an area in square feet. So make sure when you're figuring out the area, you make it in square feet, because everything is in cubic feet per minute, and feet per minute is the velocity. So it doesn't have to do with inches. You have to make sure you convert it. So doing the area of the circle, pi r squared, it gives us the area. And then divided by 144 to get the area in square feet. So that gives us 14.74803218 feet squared. So this times this equals this. This divided by that is going to give us our feet per minute. So 2100 divided by 14.74803218 gives us 142.392 feet per minute. Yeah, hopefully that makes sense. Number 20 was just figuring out the area of a cheek of an elbow. So I drew the cheek of the elbow here. So it's 22 by 15 with a 12-inch throat. In green, I actually made it out where it's a full circle, because all we're trying to do is figure out the area of a quarter of a circle. So, and to find the cheek area of the cheek of an elbow, it's a small circle and a large circle, right? Small circle, large circle. So I need to find the area of the large circle divided by 4, because we're only doing a quarter of it. And then we're going to minus the area of the small circle divided by 4. So area of the small circle divided by 4 gives me this little piece of pie. The big one gives me this piece of pie. Take this piece off the big one, and I'm just left with the area of the cheek. So the large one, 22 plus 12 is 34. So 34 squared times pi divided by 4 is 907.92. The small one is going to be 12 as the radius. So 12 squared times pi divided by 4 is 113.097. So this one subtracted off of this one gives us a total answer of 794.823 square inches. Moving on to 23. Sorry, this one had to do with RPM. What it's going to change when we do a 4-to-1 ratio to a 3-to-1 ratio. So I actually drew out the two fan belts and the fan shivs. So a 4-to-1 is going to look like this. When the large one spins 1 rotation, this one moves 4 rotations. So 3-to-1, this one moves once, this one moves 3 times. So this shiv here is going to be a little bit bigger in diameter than that one. So this one's actually pretty simple math. So a 4-to-1 ratio, if this one here gives us 600 rotations per minute, all I'm going to do is go 600 divided by 4, which gives me 150. And then I'm going to take that 150 and multiply it by 3 on this 3-to-1 ratio. And that gives me a 450 RPM then for this new set here. RPM is rotations per minute. I can actually divide this by 60 and get 10 rotations per second. You can work it out that way, but because it's minutes to minutes, you don't really have to do that, because over here I'd end up multiplying it by 60 again. So it's just easier just to do it like that. 600 divided by 4 gives you that, and multiplied by 3 gives you the new RPM. So it's pretty simple math on that one. Okay, number 24 had to do with calculating the length of the fan belt. Hopefully you can see this okay. So we have a 300 millimeter large diameter sheave, a 150 millimeter diameter small diameter sheave, and then we have a length of 900 millimeters from center to center. So I drew it out in red here. So basically what we're looking for is the length from here to here, so half of the circumference of this one. And then from here to here is half the circumference of that one, plus this sloped length here and this sloped length here. So this one's 300 millimeters, so 300 times pi divided by 2 gives us from here to here, which is 471.238898. 150 times pi divided by 2 is going to give us this length here, which is 235.619449. And then I drew these little triangles here. So we know the base of this triangle is 900. That shouldn't be there. The difference between here and here is 75 millimeters, right? Because half of this is 150. So, and from here is 150. So 150 is going to be left over, and that's cut in half, so that's 75. So 75 squared plus 900, or 900 squared plus 75 squared, square root, a squared plus b squared equals c squared, gives us 903.11959. And then we just add them all together. So 471, 235, 903, 903, and I've already rounded this one off because they wanted the closest full millimeter. So we end up with 2,513 millimeters. Number 25. When I was writing this question, I actually meant for these both to be 10-inch throat radiuses. That's why the original answer I gave was different than what it actually is. So hopefully, well, Jordan pointed it out that that one's 8 and this one's 10. So I have to actually make 2 of these little triangles in here. So, and I pulled them out. So our hypotenuse on this one is going to be this length here. Like if I was to swing an arc right from there, it's the same height as all the way from here to here. So 10 plus 10 is 20. So that hypotenuse there is 20 inches. Then the length from here to here is from this point to the center of here, and that's 14. So half of 14 is 7. 10 and 7 is 17. And we're looking for this angle here, because now with this arc, I want to find out the length of that arc. And we're going to do that by angle divided by 360. And then using that radius times 2 times pi times angle over 360. So if we do that angle divided by 360, we'll know what to multiply in that formula. And then the same on this one. From here to here is 18 inches, which makes our hypotenuse 18 inches. From here to there is 8 plus 7, which is 15 inches from here to here. So 15, 8. And here's the actual, I actually wrote out the SOHCAHTOA here, opposite and hypotenuse. So from this angle, that's the opposite. This is a hypotenuse, so it's going to be a sine function. We have 2 numbers. We're looking for an angle, so we're going to use the second function. So 15 divided by 18, second function sine, or don't forget the equals though. 15 divided by 18 equals, and then second function sine equals 56.44269.024 degrees, and then divided by 360 gives us this decimal here, which we're going to use in the formula. And then this one, 17 divided by 20 equals second function sine, 58.21166.938, divided by 360 gives us this decimal. And then I can apply it to this formula. So in this one here, radius is 18. Radius times 2 times pi times 0.15678,525 gives us 17.73199,403. So that number there is literally the length of from here to here. And when I work out the formula on this side, we have a 20.3197058, and that's the length from here to here. Add those two together, and we end up with this total of 38 1/16. All right, last one. This one here, I was being a little bit lazy when I came up with these dimensions because they don't technically work out for a 45-degree elbow. You know, and hopefully you guys recognize that. The point of this though is understanding how to get or how to apply the math. With the dimensions I gave here, you'd actually have to calculate what angles these two elbows would be to make this work out. But just to keep it simple, this is the whole process. So there's a 45-degree elbow here, 45-degree elbow there. We're looking for the length of the duct in between here. From center to center, we have an offset of 26 3/16. From the outside edge to outside edge, a height of 38 1/8. So using that, this is a 12x8 elbow with a 12-inch throat radius. It's 45 degrees. We're gonna make those seam heights. I don't know if you guys remember last time I showed that. So we need to figure out a seam height to the center of the elbow because I have a green triangle here. This is what we're trying to get to. So this is gonna be a tan function. So I pulled this triangle out down here. So half of 45 is 22.5 degrees. The throat radius plus half of the elbow here is 18 inches. So tan 22.5 times 18 gives us a seam height, this height here, of 7.44 or 455844123. I multiplied it by 2 because anytime we're going to use that seam height, we're going to be subtracting it twice basically. Once here and once here. So that's twice off of the height. So I'm going to take this height, subtract 2 seam heights, which is this number here, off of it, which leaves me a total of 23.21331175. So now this part of the triangle is that long. So here's the green triangle I drew here. I pulled it out here, 23.21331175. And then from here to here does not change, the offset on the triangle. So this length here is still 26 3/16. I just changed it to a decimal there. Now it's going to be a squared plus b squared is c squared, or the square root of c squared. So that gives you 34.99489961. That's going to be the length from here to here, or here to here. And then you can see for me to find the piece of duct here, from there to there, I'm just going to subtract that seam height off there and here again. So that number, I've subtracted the seam height twice. That's the 14.91 or 911, etc. That gives me a total of 20.08321136. Change that to the nearest 16th is 20 1/16. So the duct from there to there will be 20 1/16. Like I said, for this to be proper with 45s, if this is 26 3/16, then this here should be 23 3/16. So we are kind of cheating this one a little bit, but that is the process to how you figure out that piece of duct in the middle. Hopefully that makes sense. But yeah, that's pretty much it. If you guys have any more questions, give me a call or a text like normal, or an email.